So in this section, we are going to discuss limits at infinity. And I actually wrote down, these are important. You do need to know this concept right here. So if you have the limit of any rational function, meaning it has a fraction in it, there's a number on the bottom, there's a variable on the bottom, and you're doing the limit as x approaches either infinity or x approaches negative infinity. So I'm just going to kind of do some stuff on the side. You don't need to write this down, but you can if you want. So like if you were to plug in c over infinity, if you were to plug in infinity to that power, what you would have is you would have a really, really small number over a really, really big number. If you have something like that, your answer is going to approach 0. Feel free to try it. You can go on your calculator and you can try like 1 over 1,000, and then you can try like 1 over, just add a bunch more zeros. Eventually, you're going to get to a point where your 1 or any constant over a really, really, really big number, eventually your calculator is going to round it so much that it will say 0. So you are going to find that these are both equal to 0. Oh, I did actually write here that in this case r is positive. Just keep that in mind. But basically the big idea is if you have a small number divided by a really big number, your answer is going to approach 0. So I'm going to show you how you can evaluate some of these limits. If you found that you substituted in infinity for this, you would find that you would get like 2 times infinity minus 1 over infinity plus 1. Well, that would just be infinity over infinity, which is what we call an indeterminate form. So we had an indeterminate form previously in the last section. We had 0 over 0. That was an indeterminate form. If you have infinity over infinity, that also is going to be considered an indeterminate form. So we have a method that we're going to use to solve this out. I'm going to be completely honest. This method I'm showing you now, it's really long, and you most likely are not actually going to use it because I'm going to show you a shortcut in just a few minutes. But I do want to show it to you for now, just so you have this under your belt and so just in case you need to use it. Okay, so basically what our method is going to be is we are going to take all of our terms and we're going to divide them by the highest variable of the denominator. I'll show you what I mean. So I wrote this out. Divide all terms by the highest degree variable of the denominator. Sorry, it ended up being a little messy. So I'll show you how to do that. So in my denominator, my highest degree variable is x. So what I'm going to do is I'm going to take all of my terms and divide every single part of this fraction by x. So then from there, what I can do is I can rewrite this equation. In my numerator, I end up with 2 minus 1 over x. Denominator, I end up with 1 plus 1 over x. So now what I can do is I can substitute in infinity for x. So if I get 1 over infinity, I know that 1 over infinity is going to approach 0 when I'm finding the limit. So I end up getting 2 minus 0 over 1 plus 0, and my answer for that limit is actually going to be 1. So for this next one, I would like you, if you feel like you know what to do, I'd like you just to pause and try it. If you're still like not quite sure, you can just watch me do it. So same process as in the previous one. I am going to go through and divide every term by the highest degree variable in the denominator. In this case, it is x squared. So when I do that, this changes to limit as x approaches infinity of 3x over x squared plus 5 over x squared over 4x squared over x squared plus 1 over x squared. So hopefully you'll see why I do this in just a sec when I show you the next, I'll show you the next two steps. So I'll give you the simplified form of this. Okay, so then if I were to go through and substitute in infinity, I would end up with 3 over infinity plus 5 over infinity squared, which by the way is infinity, over 4 plus 1 over infinity squared. So now I want you to think back to the very beginning of the video when I gave you the limit as we approach infinity. So 3 over infinity, that's going to be a small number over a really big number. That equals 0. 5 over infinity is equal to 0. 4 is just going to be equal to 4. 1 over infinity is also going to be 0. So in the end, I get 0 over 4, and my final answer for that is just 0. So let's try one more, and then I'm going to show you the shorter way to do this. So for number 3, you're welcome to try it on your own, but I think it might be best if we do this one together. We are going to start by dividing everything by the highest agreed term in, or the highest agreed variable in the denominator. That is x to the third. Be careful, you're not going to do the x to the fourth here. We're looking at whatever's in the denominator. So we get 5x to the fourth over x cubed minus 2x squared over x cubed over 4x to the third over x cubed minus 1 over x cubed. So then we get, I'm going to simplify it out. We get this right here. So now I'm just going to go ahead and try to substitute in that negative infinity. So I get 5 times negative infinity minus 2 over negative infinity over 4 minus 1 over negative infinity, and that would be cubed. So it's kind of like I got negative 5 infinity. Well, if you take infinity and multiply it by 5, you're going to get infinity. So I'm just going to leave that as negative infinity in the numerator. I end up getting minus 2 over negative infinity. Again, remember, we're dividing by a really, it's actually a really big negative number. It's a crazy negative number, which is just going to be 0. 4 is going to stay as 4. Again, in the 1 over negative infinity to the third is going to be another like really 1 over a really big number, and that ends up approaching 0 also. So my final answer is negative infinity over 4. Now, infinity is huge, so if you just add, subtract, multiply, divide numbers to it, they're not going to affect it at all. And so my final answer for this one is actually going to end up being negative infinity. Okay, so this stuff always is kind of weird for people. I am going to tell you that there are other ways to do this problem, and I'm going to actually show you a way right now. I have a feeling you're probably not going to use this method, but I feel like I should just teach it to you so you can see it. You might need it at some point, so it's a good one to just be able to do. So let's go ahead and we'll do the shorter method. So if you remember, a few weeks ago we talked about horizontal asymptotes, and actually limits in infinity can be found by getting those horizontal asymptotes. So the shortcuts for finding limits of rational functions at infinity are going to be the same as the shortcuts methods for finding horizontal asymptotes. So let's go ahead and go through these. So the first case is when you have the degree of your numerator less than the degree of your denominator. And in this case, you are always going to have your limit equal to 0, which is the same as if you have that case and you're finding the horizontal asymptote. So, for example, if I'm finding the limit as x approaches negative infinity of 5x squared over 3x to the fourth minus 2x, that is just going to be 0. So the next case you also might remember from when we did horizontal asymptotes. If you take the limit of this type of function as x approaches either infinity or negative infinity, you are going to, your answer will just be the leading coefficient of the numerator over the leading coefficient of the denominator. So if you look at this example here, leading coefficient of my numerator is -8. Leading coefficient of the denominator is 5. So my limit will be -8/5. The final one is unfortunately a little bit harder. So for this case, the best way to do it is probably to use the methods that we did previously. There are a few other things that you can do. I'll show you a single shortcut that works most of the time. However, if you want the method that works all of the time, you're going to have to do the one that we did previously. So I'll give you an example of that. So for this type of problem, I'm going to do what I just did and divide everything by x squared. And when I simplify that out, I do end up getting 3x minus 5 plus 2 over x over 9 minus 3 over x squared. If I substitute an infinity for everything there, for the 3x, if I were to substitute infinity, sorry, this should be negative infinity, I lost that. For 3x, if I substituted in negative infinity, I would end up with 3 times negative infinity, which would just give me negative infinity. Then I have minus 5. 2 divided by negative infinity is going to approach 0. Then I have a 9 down there. And then 3 divided by negative infinity squared is also going to approach 0. So actually, in the end, this would go approach negative infinity. So I'm going to show you something weird that sometimes happens. So let's say I have the limit of 3x to the third over x minus 1 as x approaches negative infinity. So I'm going to use the method that I just did. And I'm going to divide everything by x. So I then get 3x squared over 1 minus 1 over x. And if I plug in negative infinity, I get 3 times negative infinity squared over 1 minus 0. So now I'm left with 3 times negative infinity squared. So generally, if you're squaring an infinity, it's still infinity. However, when we're working with signs here, we actually do take into account squaring that negative. So my final answer is actually going to be positive infinity.